So we're going to talk about the law of sines. There's a couple of ways that you can use them. There's different types of triangles that you're trying to solve. You can have, this is an angle, side, angle, or side, angle, angle, where you have two angles in one side. Here you have two sides and an angle, so you've got the two here with the angle. You've got a side, angle, side, or you have all three sides. You can solve any of the triangles like that. And the law of sine says that in any triangle, the lengths of the sides are proportional to the sines of the corresponding opposite angles. So in any triangle ABC, we have sine of A over A equals sine of B over B equals sine of C over C. So the sine of the angle over the side that matches, that's opposite from it, is equal to all of the other ones. So we are going to do a problem, and we are looking at tracking a satellite. So a satellite orbiting the Earth passes directly overhead at observation stations in Phoenix and Los Angeles, 340 miles apart. At an instant when the satellite is being between these two stations, its angle of elevation, remember the angle of elevation is where it rises up from the ground, is simultaneously observed to be 60 degrees at Phoenix and 75 degrees at Los Angeles. How far is the satellite from Los Angeles? All right, so let's draw a picture, because that's always worth 1,000 words, and see if we can make some sense of this. So we've got and again, my triangles don't always match what's going on in the picture. Here we have 75 degrees. Here we've got 60 degrees. They've got this A, B, and C. I'm just kind of replicating the picture. And this is LA. And then this is going to be Phoenix. And we are told that they are 340 miles apart from each other. So we've got two angles and one side. So angle, side, angle is what we're given. And we need to find out, what we're looking for is how far is the satellite from LA. So we're looking for this distance right here. Now, understand this is little a and this will be little b because they're across from each other. So this was little c. Let's focus that a little bit more. Yeah, that's a little better. Alrighty, so first thing we can find that's easy to find is angle C. So if we're looking for angle C, we know that all of our triangles are, the inside is going to add up to be 180 degrees. So we can take 180 and we can subtract 75 and 60 and we'll end up with 45 degrees. So now that we know little c, or angle C, let's look at everything that we do know. I'm going to kind of write them. I know we've got them on a triangle, but we know angle A is equal to 75 degrees, angle B is equal to 60 degrees, and little c was equal to 340. And what we're trying to find is B. We need to know what B is. So that way we have more of a picture of what's going on. All right, so now that we have this, remember our law of sine is sine of A over little a is sine of B over little b is equal to the sine of C over little c. So finding that we had to find C because the only distance we have is little c. So now we have an angle and we have a distance. So we can use that the C part. We know A here and we know this B. We need to find this little b right there. So I'm going to say that sine of C over C is equal to sine of B over B. I'm going to use that particular one. You don't use all three. We're just going to use two of them because these are the ones that I know. So this tells me I have the sine of 45 degrees divided by 340 is equal to the sine of 60 over little b. And now we can cross multiply. So b times the sine of 45 is equal to 340 times the sine of 60. So I'm going to divide by my sine of 45. So b would be equal to 340 times the sine of 60 divided by the sine of 45. Now, what mode do I need to be in when I put this in my calculator? Well, we're using degree angles. These are all degrees. So because we're using a degree angle, I don't always write them on there, but we probably should. So let me go back and put those on. Since we're putting in a degree, we have to be in degree mode. If you put it in radian mode, you won't get the right answer. All right, so let's turn on our calculator. So we have 340 times the sine of 60, and I can see them in degree mode. And then we'll divide by the sine of 45. And we'll find that it is 416 miles. So there we go. All right, so we're going to look at another problem. We're going to solve a triangle. So I'm going to try to draw another one. I think I've told you before, I am not an artist. So we've got kind of a skinny one here. So this is A, this is B, this is C. This is 25 degrees. This one is 20 degrees. This will be little b, little a, and little c. And we know those because they're opposite of our angles. And this is going to be, let's see, and we are given that C is 80.4. We're doing a side and two angles that we have here. Alrighty. So we've got sine of A over little a equals the sine of B over little b equals the sine of C over little c. So the first thing I'm going to do is find my angle of B, because I know the angle of B is going to be 180 minus the 20 degrees and the 25 degrees, which will get us 135 degrees. Now I know that I can find, I've got C, so I have to do my C's again because that's what I have. I have I've got to have one of those pairs to solve for one of them. So I have an angle C and I have a length of C. So let's go find angle or the side of A. So I'm going to use the sine of C divided by C is equal to the sine of A divided by A. So this will get us the sine. C, angle C is 25 degrees divided by the length of C, which is 80.4, will be equal to my sine of 20 divided by little a. And then we will move this out a little bit. Cross multiply again. A times the sine of 25 degrees is equal to 80.4 times the sine of 20. Again, divide by the sine of 25. And we have little a is equal to 80.4 times the sine of 20 divided by the sine of 25. As we put that in our calculator, so we'll have 80.4, we're again using degree mode, times the sine of 20 divided by the sine of 25. So little a, we have our one side is to one decimal, so we'll go to a decimal. So 65.1. So now that I have little a, the only one I have left to find is little b. Now, I will tell you at this point, I try to use what's given. Let's say you forgot your mode, and you actually were in radian mode, and you find this answer. If you use this answer, then you could get the next answer incorrect as well, and it can mess it up. So I always try to go back, because I can now use sine A and little a, and if I have to, I will. But I'm going to go back to using my C's, because my C's were given to me, and that way I know they're correct, that I didn't make a math error over here somehow. So I always try to use what's given. So if I mess up one part, I don't mess up my whole solving. So we're going to do sine of C over C is equal to the sine of B over B. So we'll have the sine of 25 degrees divided by 80.4 is equal to the sine of 135 degrees divided by B. Cross multiply, we get B times the sine of 25 is equal to 80.4 times the sine of 135. Divide by the sine of 25, and little b will be equal to 80.4 times the sine of 135 degrees divided by the sine of 25 degrees. So let's go put that in our calculator. So we have 80.4 times the sine of 135 divided by the sine of 25. And again, we'll go to one decimal, 134.5. So we have all of the pieces. Remember we talked before, there are 6 parts to our triangle, and we were given 3 of them, so we solved for the other 3. All right, so the next thing that we are going to look at is the ambiguous case. So on the ambiguous case, and what I also want you to know is we are doing the law of sines. We are dealing with angles that we're not dealing with right triangles, so we cannot use the Pythagorean theorem. That's a big key. So ambiguous case means we can actually get a possibility of 2 solutions for our triangle, just depending on what happens. Just so you have an idea of what we are talking about. All right, so we're going to solve a triangle here. And we have it's going to be a dashed line there, and we've got A and C and B, so little c, little a, little b. And we are given that angle A is equal to 45 degrees, little a is equal to 7 square roots of 2, and b is equal to 7. All right, so here we have 7, here we have 7 square roots of 2, and we are told this is 45 degrees. So we are given 2 sides and an angle. So what we want to do is, again, our formula is going to be the sine of A over little a equals the sine of B over little b, sine of C over little c. So let's go solve for one of our parts. Since we have, again, we have to have a pair that matches. So we're going to have to use our A's, and then we know the length of B, so we're going to have to solve for B. We can't do C at this point because we don't have either part of C. So we are going to do the sine of A and B. We're going to use these two here. So we'll have the sine of 45 degrees divided by its little a is equal to the sine of B divided by little b. And again, we will cross multiply. So 7 times the sine of 45 degrees equals 7 square roots of 2 times the sine of B. Now to get the sine of B by itself, we'll do 7 square roots of 2. So we have sine of 7 times the sine of 45 degrees divided by 7 square roots of 2. And we could just multiply the 7 over there instead and then just get their B. But if we always start with the same process, it's a little bit easier, I think, to remember what you want to do. Now, the sine of B, we are looking to find, so we're going to have to do the inverse to actually find that, which we've already learned. Now, if we, the sine of 45, that's something that we should know. We don't have to put that in the calculator. We know it from our unit circle. Our terminal point at 45 degrees is square root of 2 over 2, square root of 2 over 2. So the sine and cosine actually have the same value there. So we know that this will be 7 times the square root of 2 over 2 divided by 7 square roots of 2 is equal to our sine of B. Well, the 7's are going to cancel, right? We could have canceled those earlier. So now we have the square root of 2 over 2 divided by that square root of 2. We've talked before that we don't divide by fractions, we multiply by reciprocals. So now we have the square root of 2 over 2 times, this would be over a 1 square root of 2. 1 over the square root of 2. So the square roots of 2 will cancel, and we'll end up with 1 over 2. And that is going to be our sine of B. So I've kind of switched our sine of B over here. Now, that is what sine of B equals. So the sine of B is equal to 1/2. So we actually have to find the inverse. So sine inverse of 1/2 would be equal to our B. And if we put that in our calculator, so we'll do second sine inverse of 1 divided by 2, and we get 30. So our B is equal to 30 degrees. So now that we know angle B, we can go back and we can solve for the rest. We know angle B now, we can actually find angle C. So to find angle C, it's going to be 180 minus the 45 degrees plus the 30 degrees. So angle C will be equal to 105 degrees. All right, now that we know angle C, we can use our sine A over A, and we can use that, so we'll use our sine A, and we'll use our sine of C over C. So we'll have the sine of 45 degrees divided by 7 square roots of 2 is equal to the sine of 105 degrees divided by little c. Cross multiply, c times the sine of 40 is equal to 7 square roots of 2 times the sine of 105. divide by the sine of 45, not 40. Got to watch those typos. The sine of 45. So C is equal to 7 square roots of 2 times the sine of 105 degrees divided by the sine of 45 degrees. So let's go put that in our calculator. So we have 7 times the square root of 2 times the sine of 105 divided by the sine of 45. So it's giving us a big old number that's all square rooting. I'm going to use my double arrow key on my calculator and get a decimal. So it's 13.5. So C would be equal to 13.5. So there we go. We have solved for C, we've solved for B, and we also solved for angle C. So we have solved for all of the 3 parts that we did not have. All right. So we've solved for C, or for that angle. Let's go look at another angle. So we've talked about the ambiguous case, and it's coming up. I realize that is not the ambiguous case problem, but that way we've covered the things that could happen. You can actually get 2 solutions to a problem. So let's go solve another problem. So we are given that angle A is equal to 43.1 degrees. Little a is equal to 186.2. And little b is equal to 248.6. So again, you have to use the law of sines, you have to have 2 of those pieces that match, where they're both A, they're both a B, or they're both a C. All right, let's go see what we can solve here. So again, sine A over little a equals the sine of B over little b equals the sine of C over little c. So the only thing we can solve for is sine of B, because we have these 2 and we have little b. We again can't touch C because we don't know the angle or the side, and we can't find the sine of C. We can't find the C angle until we know the angle of B, because we have little b. That's the one we're going to have to go with. So we are going to have the sine of 43.1 degrees over 186.2 is equal to the sine of B divided by 248.6. Cross multiply, we end up with 248.6 times the sine of 43.1 degrees over 186.2. Whoops, I jumped ahead, sorry about that. We are going to divide by that, so ignore that for just a second, sorry. We'd have 186.2 times the sine of B. So we'd have that part. Now we got to divide by 186.2 on both sides. So now we have our sine of B. I'm going to flip the sides. Is equal to 248.6 times the sine of 43.1 degrees all over 186.2. I was thinking ahead a little bit there. All right. So let's go put that into our calculator. We don't know the sine of that, so we're going to actually have to just plug it all in. All right, so we have 248.6 times the sine of 43.1 divided by 186.2. All right, so the sine of B is equal to 0.9122 65, and it continues on. We're going to actually use this here in a second in our calculator. We're going to use some of our calculator skills there. So in order to find angle B, we need to do the sine inverse of that number. So 0.91225. What I'm going to do is do the second sine inverse, second answer. I can put that answer straight in with my second answer. The answer key is right here. And it'll get me 65.8. So our B is 65.8 degrees. All right. Now, what we need to understand is that there's another option on this, and this is where you can have the ambiguous case. And we know this is the ambiguous case because it has told us that. And we've got a little bit of a picture here. So this is our B, here's our A, here's our little a. So our angle B is the angle that we found of 65.8, or it could be 180 minus that. This can be a second triangle. They don't happen very often, but I'm just letting you know that it could also be that. So this would be angle B1, or we can have angle B2. And we would find that by 180 minus the 65.8 that we found, which is 114.2. Now, we know this can work because, so this is our angle B2, and angle B2, if we add our angle A that we had of 43.1, we're still less than 180, so we'd be okay. So let's go solve for one of the triangles, and then we'll finish solving for the other. In most cases, you won't have an ambiguous case, so don't stress about it. You'll be all right. All right, so let's solve for our triangle with A sub 1, B sub 1, and C sub 1. So angle C sub 1 would be equal to 180 minus the 43.1 that was our A and the B that we found of 65.8. So it's 71.1 degrees. All right, so we have our three angles because we were given one and we found two. And we have one side here, two sides there, so we only have side C to find. So we're going to go back and use our angle, our sine of A over A. So we will have the sine of 43.1 degrees over that 186.2 is equal to the sine of 71.1 degrees, which is our angle C, over little c. And we will do our cross multiplication. So we end up with C times the sine of 43.1 degrees is equal to 186.2 times the sine of 71.1 degrees, divide by the sine of 43.1, and our C would be equal to 186.2 times the sine of 71.1 divided by the sine of 43.1. Now I will tell you, when you're solving things like this and you know what it's going to look like, rewrite it so it's very clear, especially if you're in a course and you're doing an exam. Write that C equals that so the teacher can actually see what you're trying to do and you can make your math more clear. All right, so let's go put that in our calculator. 186.2 times the sine of 71.1 divided by the sine of 43.1. And we end up with 257.8. So we have solved for our 3 parts. All right, now let's go solve for the second triangle. So for our second triangle, we're going to use this angle for our B instead of the smaller one. All right, so we again still just have to solve for angle C, and we need to solve for our side of C. So our angle C sub 2 would be equal to 180 minus our original A, 43.1, and our angle B here of 114.2. And that will get us an angle of 22.7 degrees. So now that we have angle C, let's go find our side of C. So we're going to again use our A over A, so the sine of 43.1 degrees divided by 186.2 will be equal to the sine of 22.7 over little c. So we'll cross multiply. So c times the sine of 43.1 degrees is equal to 186.2 times the sine of 22.7. Divide both sides by 43.1 degrees. So our side of C equals 186.2 times the sine of 22.7 divided by the sine of 43.1. And we'll go put that in our calculator. So we have 186.2 times the sine of 22.7 divided by the sine of 43.1. And always make sure you close the parenthesis on your angle. So we're going to get 105.2. So 105.2. So that would be the second triangle. So we actually, oh, and I should put, this would be C sub 2. So we actually do have two triangles because it worked out that our B could be either one. And so you can see in the drawing, we ended up with one big triangle, or we could end up with the smaller triangle. So, not too common to happen, but it can. All right, so let's go look at another one. This one will be a no solution problem. This is going to be a side-side angle with no solution. So just so you understand, it's not going to work out, but it's all good. All right, so we are given that angle A is equal to 42 degrees, little a is equal to 70, and B is equal to 122. Again, we're only given the A's that match, and we're given B. So we're going to use our sine of A over little a equals the sine of big B over little b. And of course, it also equals the sine of C. But we'll get to C when we get there. All right, so we're still using the same thing. I'll write it there just so we know that we're still using the same formula. All right, so we'll have the sine of 42 degrees divided by 70 is equal to the sine of B over 122. So we'll cross multiply again. So we'll end up with 122 times the sine of 42 degrees is equal to 70 times the sine of B. So we'll divide by 70 on both sides. So our sine of B will be equal to 122 times the sine of 42 degrees over 70. So let's go put that into our calculator. All right, so we have 122 times the sine of 42 divided by 70. And so we get that our sine B is equal to 1.16619 dot, dot, dot. So we know then that the B will be equal to the sine inverse of that 1.16619 dot, 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 dot part. So now we'll do second, sine inverse, second, and I'm doing that answer thing again. So it just puts it in, so I don't have to type it in. And I got a domain error. So what is our problem there? If you recall, let's go back and look. Our domain has, let's see if we have that in this one. The domain for our sine is, do we have that on here? We have it right here. So for our sine, here is our domain and here is our range. For the inverse of sine, it has to be between -1 and 1. Well, this is greater than 1. So this will be a domain error because it's too big. So this has no solution. So that's also a possibility where you will have a problem that will not work out. And again, the ambiguous case won't happen very often. It's only going to happen if you can take the second angle and then you can still solve for the second triangle.